This lesson we're going to talk about some new terms probably called centroid and orthocenter, and they're all dealing with triangles. So there's some definitions that we need to know first. First one is altitude and median. So the altitude of a triangle is when you take from any vertex and you draw a perpendicular line to the opposite side. So that is also called the height of a triangle. So this is, key things to know is it's from one vertex to an opposite side and it forms a right angle. That is the altitude. The median of a triangle is a segment from one vertex to another that splits the opposite side into two equal parts. So it's the midpoint. So this point right here is the midpoint of the opposite side. So with any given triangle, you will have three altitudes because you have three vertexes you can draw and three medians because you can always take make a line from the vertex to the midpoint of the other side. So a point of concurrency is where three or more lines intersect. So when we're talking about a point of concurrency with triangles, we have two different definitions. One is the orthocenter. This is where the altitudes of a triangle intersect. So if I draw a triangle and I draw each of the altitudes from the vertex to the opposite side, this point where they all meet is called the orthocenter. So orthocenter is where the altitudes meet. The centroid is where the medians of the triangle intersect. So when we draw and bisect the opposite side, then this point is called the centroid. Now in your video, it kind of talked about balancing a triangle. So the centroid is the center of the triangle and it's always inside the triangle. If you remember in the video, he balanced a cutout paper triangle on his finger. So when we think about centroid, think center, always inside the triangle. So let's look at this statement. Manny says that the diagram shows a centroid. Is he correct? Why or why not? Well, what do we know about these things? We know that we're forming a right angle, and this is not, it's not cutting this opposite in half. So this is actually the altitudes of this, and an altitude, where the altitudes meet, is called the orthocenter. So because the centroid is where the medians meet should be the correct answer. So this is showing the orthocenter where the altitudes meet, but a centroid is where the medians meet. You're just going to want that in your notes and in your definitions so you can refer to it and understand what those are. So something about orthocenters. Centroids will always be in the center of a triangle, but the locations of the orthocenters, which is marked with the letter O here, depends on the type of the triangle. If it's an acute triangle, where all angles are less than 90 degrees, the orthocenter will be inside the triangle. So if it's acute, it's inside. If it is an obtuse triangle, which we have this triangle ABC here, the orthocenter is actually outside the triangle, because if we draw a line that makes a perpendicular side, if we're going to A, well, B is not going to be, the altitude is outside the triangle, and the same with this one. So where if we extend those lines, it's going to be outside. And if you'll notice, C and O are right on the same spot, because in a right triangle, AC is an altitude to CB, and BC is an altitude to AC, and then this is the altitude here. So those all meet on the triangle. So put that in your notes. Make sure you know an orthocenter is depending on what type of triangle it is, where that point of concurrency is, where that orthocenter is. So let's take a look. Let's practice with orthocenters and centroids. Which figure has an orthocenter outside the triangle? Now remember what we just learned. If it's an acute triangle, they will meet inside. Acute triangle, they will meet inside. A right triangle, they will meet on the triangle. And an obtuse triangle, they will meet outside. And because this is the only one with an angle larger than 90 degrees, this is our obtuse triangle, so the orthocenter will be outside this triangle. So centroids are kind of handy because they're going to help us solve a lot of problems of distances and between different points in a triangle. So the centroid ratio theorem says that along each median in the triangle, so if we have a median, so AD is a median, BE and CF are also medians. We're going to just look at AD. The distance between the vertex and the centroid, so here's our vertex and here's our centroid, is 2 times is twice the distance between the centroid and the opposite vertex. So if I were to write this, for example, if this were 4, this would have to be 2 because AG is 2 times GD. Or in other words, if this is x, then this will be 2x. So that is a really important theorem to know. We're going to do lots of problems using that theorem. So let's use this centroid ratio theorem. So G is the centroid, meaning it connects, it's where all the medians meet. So if G is the centroid, then what is the value of x? Well, we know from the vertex to the centroid, x plus 7 is equal to 2 times the distance from G to D. So that's 2 times x minus 15. So the vertex to the centroid is the longer one, twice as the other. And then we're just going to solve for x. We have x plus 7 equals 2x minus 30 when we distribute this. And then we subtract, so we get, I'm going to subtract x from both sides, and I'm going to add 30 to both sides. So that's 0. We have 37. 2x minus x is x, and 30 minus 30 is 0. So x equals 37. So that's just our value of x. So what is the length of segment DG then? Well, DG is x minus 15. So we just put in 37 minus 15, and that gives us 22 units. What is the length of segment AG? Well, there's 2 ways you can do this. You could put 37 in for that and add it, or you can just double this value right here because this is twice the length. So 37 plus 7 is 44, and 2 times 22 is also 44. Now it's saying what is the length of the whole segment? Well, the whole segment is just the addition of those 2 segments. So 22 plus 44 would be 66 units. So make sure when you're solving these, you know which segment they're talking about to find. So if we're going to use it to find the length of the whole median, so that's what this is asking. NR is our whole median from N to R. Well, we don't know. We've got to find little n, but we do know that 9n minus 12 is equal to 2 times 3n. Remember, the vertex to the centroid is twice as long as from the centroid to the opposite side. So let's solve this. 9n minus 12 equals 6n. I'm going to add 12 to both sides and subtract 6n. So I get 3n equals 12. Divide by 3. So n equals 4. Is that my answer? No, it's asking, that's just the value of n. Now we need to find the length of NR. So we're going to substitute into either one of these. I'm going to put it into 3n. So 3 times 4 is equal to 12. So this length is 12. I know this one is 12. I know this one is double 12, so that's going to be 24. And then to find the length of the whole thing, I simply add 24 plus 12, and I get 36. Okay, pause the video and try this one out. All right, take a look at this. So first thing we need to do is find the value of x. We want to find GF, so we've got to take a look at that. So first I've got to find x somehow because there's an x involved here. So I do know that BG is 40 and GD is 9x plus 2. So I can solve for x because I know that 40 is twice 9x plus 2, and I get x equals 2. Then I'm going to take x equals 2 and I'm going to substitute it into this one because that's the one that's on the median of GF, the GF is on. So if I substitute 2 in for here, I get 19 times 2 plus 14 is equal to 52. So AG is equal to 52. Now to find GF, I use the centroid ratio theorem, and I said that the first part is I say 52, ignore this little part down here for a second, 52 is equal to twice GF. Divide by 2, so GF is 26. So let's take a look and if we can see where Tracy made a mistake. So she put 16 is equal to 2x, 2 times 2x. That's true. This section is twice that. So 16 equals 4x, x equals 4. Then she substituted in 8 times 4 is 32. So we have BG equals 32. And now she says GF is equal to 2 times 32. But if you notice, this line right here should actually be, so if this is 32, 32 should be equal to 2 times GF. So this is kind of like what we did in our last one. So right here, she made a mistake because she did it opposite of what she should do. So BG is equal to 2GF is the correct thing that she should have done. That was her mistake. All right, let's do another one. Pause the video and see if you can figure out what is the length of SW. So this is the section right here that we're looking for. SW. Pause and see if you can find that out given the information you know. All right, you'll notice that SW, we're not given enough information yet, but we know that 4m plus 8 is twice 3m minus 1. So we can solve for m, and we find that m equals 5. If we go through this and get 0 and 0, so we have 2m equals 10 and m equals 5. Once we know m is equal to 5, we can substitute into this one. So 2 times 5 plus 12 is 22. And we know that 22 is twice the length of SW. So we can set that up and find out that SW equals 11. So if we're going to find the length of a median, here's another example. Pause the video and work through this one. These are a lot of similar ones, but it helps to get practice in making sure you understand what the correct ratios are. So notice we're finding out the length of AE in this one. So I went and marked that one so I know exactly what I'm looking for. Again, I don't have enough information here, so I'm going to find x by setting 3x plus 6 is equal twice 2x minus 1. I get x equals 8. Once I know that x equals 8, I can find AG. AG is 2 times 8 plus 10, which is 26. Once I know AG, I'm looking for the whole segment. So I still need to find GE, and I know that twice GE is 26. So I just divide 26 by 2 and I get 13. And now my final answer is I add AG plus GE to get the length of the whole segment, and I get 39 units. So let's take a look at these proofs. The instructions spent quite a bit of time going through these proofs, and there's a link here that you could go through all the proofs, but I just want to walk you through it because sometimes you get caught up in all the letters and numbers. So in order to prove that the medians of an isosceles triangle meet at a point, show that the midpoint of the side, so like an F, lies on the line containing the opposite vertex, which is A. So we want to show that F lies on this line and the point where the two medians intersect. So we want to show that the vertex, this point, and this point are all on the same line. That's basically what it's saying, where the other two medians intersect and on this line. So if BD and EC intersect, we want to show that A and F and G are all lying in that same line as well. So it goes through this equation and sets up things. So what is the equation of BD simplified? Basically what they're saying is here's our point slope form, and they're taking C0, this point right here, and substituting it in. And then if we're just going to simplify this, that's all you're asked to do. So it's just going to be like distributing this and this. And so if we have 2b over 2a minus c times x, well, that's this one and this one have that in here. So we've narrowed it down to these two possibilities. And then we take a look, well, 2b times c is 2bc. So this is, and then over 2a minus c. So this is the correct simplification. It's just a matter of distributing. Then the next section, it goes through and it simplifies and combines like terms, and then it's basically saying what is the y-coordinate. We just need to simplify this. So if I take a look at this bottom one, I notice I have 2bc and minus 6bc. So I'm going to simplify that first. So I have 2ab, and 2 minus 6 is minus 4bc all over 3 times a minus 2c. Then I think, what can I factor out of this top section? Well, I have a 2 can be factored out of both of them, and they both have a b. So I have 2 and b, and then I'm left with a minus 2c. And then I have 3 times a minus 2c on the bottom. And then because those are the same, those will factor out to equal 1, and so we're left with 2b over 3. So the y value is 2b over 3. So it's just walking you through simplifying those things. And then finally, is this on the midpoint? Does it lie on that? Again, we're basically going to simplify. We're substituting into b into this, and we have b over a plus c times a plus c, and those will cancel out, and that equals b. So b equals b. So yes, because B equals B.